The possibility of life on Mars has piqued curiosity of scientists for ages. NASA's Perseverance rover, which has been hunting for signs of ancient life on the red planet, has stumbled upon a strange object.
Mars, the red planet that has both haunted and fascinated us for centuries. Mars. By the end of this decade, humanity could be walking on its dusty surface, marking the start of an unprecedented journey. NASA aims for the 2030s, but the deadly challenges waiting for us are beyond anything Earth has to offer. From planet-wide dust storms to temperatures so extreme they could freeze the air itself, surviving on Mars will take more than just a good plan.
So when we go to Mars, we have to be willing to stay for a period of 2 years. It's a proving ground for how to live and work on another world in a place where you know you can make it home safely if something goes wrong.
It will require cutting-edge technology and unthinkable ingenuity. What forces are lurking on Mars, ready to challenge the first settlers? And can we truly conquer them? The deadly journey to Mars. Imagine spending 3 months in a cramped spacecraft, completely cut off from the Earth, as you travel through the vast emptiness of space. Your only hope of survival is the thin shield of metal around you and the advanced technology keeping you alive. But as you exit Earth's protective magnetic field, the real danger begins. Without the planet's protective shield, you're exposed to deadly solar radiation, cosmic rays, and the brutal vacuum of space. Could this be the most dangerous journey humans will ever undertake? The journey to Mars is not like anything humanity has ever faced before. The trip itself lasts about 3 months, but that's just the beginning of the real danger. As soon as the spacecraft leaves the safety of Earth's magnetosphere, astronauts are vulnerable to harmful radiation that could damage their DNA. This radiation exposure is a threat that can't be ignored. Prolonged exposure could cause serious health problems, including cancer, heart disease, and neurological damage. The real challenge isn't just reaching Mars, it's surviving the journey there. To protect astronauts from radiation, scientists have been developing innovative shielding techniques. One of the ideas is using water as a protective barrier. Since water is rich in hydrogen, it's an excellent shield against cosmic radiation. If enough water can be stored on the spacecraft, it could provide not only life-sustaining hydration, but also protect astronauts from radiation. But there's a catch. How do you store that much water on a spacecraft without overwhelming it with weight? Another potential solution is to generate a magnetic field around the spacecraft. This idea is inspired by Earth's magnetic field, which protects us from solar wind and cosmic rays. Unfortunately, creating such a shield with current technology is still impossible. It would require a massive amount of energy to generate the kind of magnetic field necessary for protection. This technological hurdle could be one of the biggest obstacles standing in the way of a manned mission to Mars. While these protective measures are being developed, they still remain theoretical. No one knows for sure if they will work the way scientists expect. Even the most cutting-edge technology may not be enough to fully protect astronauts from the dangers of deep space. As the clock ticks down to NASA's goal of sending humans to Mars, the question remains: can we find a way to safely get astronauts to Mars? Or are we pushing the boundaries of human endurance too far? But the challenges don't stop once the spacecraft reaches Mars. If the journey itself is hazardous, the Martian environment promises to be even more unforgiving. With temperatures plummeting to negative 125 degrees Celsius at night, the surface of Mars is a frozen wasteland. How can humans survive in such a hostile environment? What technologies will be essential to keep future Martians alive? NASA's plans for a Mars mission are ambitious, but they will need to tackle the environmental extremes the planet offers. From protecting astronauts from radiation to ensuring they can withstand Mars's bitter cold, the journey to Mars will demand a level of ingenuity never before seen. The next step is to figure out how to survive once we get there. And that brings us to the next deadly challenge: the Martian atmosphere. Will humanity's quest for Mars colonization succeed in overcoming the deadly radiation and harsh environment, or is Mars just too hostile to conquer? Surviving Mars's harsh atmosphere. What happens when you land on a planet that doesn't even have the luxury of a breathable atmosphere. The Martian atmosphere is 100 times thinner than Earth's, offering little protection from cosmic radiation, and the air that is there is 95% carbon dioxide. How will humans survive in such a harsh and airless world? Mars' atmosphere is one of its most deadly features. Unlike Earth, which has an atmosphere rich in oxygen, Mars has barely any breathable air. This presents an obvious challenge. Humans will need to either create their own oxygen or bring it from Earth. Without it, survival is impossible. One of the main concerns for NASA is how to generate oxygen on Mars, since relying on Earth for every supply is impractical. This could be the key to humanity's survival. NASA has already begun experimenting with technologies that could convert carbon dioxide, the primary component of Mars's atmosphere, into breathable oxygen. One of these technologies, known as MOXIE, or Mars Oxygen In Situ Resource Utilization Experiment.
A microwave-sized box on the Perseverance rover took oxygen from the Martian atmosphere.
Was tested aboard the Perseverance rover in 2021.
Reaching 16 feet and flying for nearly a minute. We also learned the Perseverance rover converted some of Mars' thin atmosphere into pure oxygen.
MOXIE works by extracting oxygen from carbon dioxide, a method that could be vital for future colonies. But the challenge is massive. If it works, it will need to be scaled up significantly to support human life. However, converting carbon dioxide into oxygen is just part of the equation. Mars's atmosphere is so thin that it can't trap heat the way Earth does. This means the temperature on the surface of Mars can drop drastically at night, reaching negative 120 degrees Celsius. During the day, temperatures can rise to a relatively toasty 20 degrees Celsius at the equator, but this is still far from comfortable. To survive these extreme swings, settlers will need to create habitats that can withstand the cold and keep them warm at night. NASA's concept of a Mars habitat involves using the planet's natural resources to help insulate living spaces. One potential solution is building habitats out of the planet's own soil, a technique known as regolith-based construction. Using 3D printing technology, the idea is to create structures that are both insulated from the cold and shielded from harmful radiation. But these habitats will need to be airtight and capable of maintaining a stable temperature, a tough feat in such a volatile environment. Another idea being explored is creating pressurized habitats. These would be sealed, life-supporting environments where astronauts can breathe normally, and temperature and pressure are carefully controlled. But this comes with its own set of challenges. How do you keep a habitat pressurized on a planet where the atmosphere can barely keep the air inside from escaping? In addition to all this, Mars's thin atmosphere means it has little to no protection from meteors. Unlike Earth, where the thick atmosphere burns up most meteors before they hit the surface, Mars' atmosphere is so thin that small meteors can strike the surface. Future colonists will need to build their habitats with materials strong enough to withstand such impacts. How can we ensure that these fragile outposts on Mars stay intact in such a hostile environment? Even with these potential solutions, Mars remains one of the most inhospitable places humans could ever settle. The atmosphere alone could make colonization an impossible feat. But if we can overcome these challenges, the next problem awaits. How to survive the dust storms that rage across the Martian landscape? Can we conquer Mars' deadly atmosphere and create the necessary conditions for human life? Or will this challenge prove too great for us to overcome? The dust storms of Mars. Imagine being on Mars, only to have the entire planet swallowed up by a massive dust storm. What was once a dusty landscape stretching for miles now becomes a chaotic wall of dust, blotting out the sun for weeks. How would you survive such a storm, and what would it mean for future Martian colonists? Mars is famous for its violent and unpredictable dust storms. These storms can grow from a small localized disturbance into planet-wide events that last for months. Once a storm reaches its peak, it can envelop the entire planet, blocking sunlight and causing temperatures to plummet. This presents a massive challenge to any human colonies hoping to survive on the Red Planet. In 2018, a massive dust storm knocked out NASA's Opportunity rover. The storm, which covered the entire planet, caused the rover to lose power as its solar panels were completely covered with dust. With no sunlight to charge its batteries, Opportunity was forced into hibernation mode, and eventually it stopped communicating with Earth. This incident highlights the dangers posed by Martian dust storms and the unpredictability they bring. These dust storms are not just inconvenient, they could be deadly for any future settlers on Mars. During a storm, temperatures can drop significantly, and the lack of sunlight could make it difficult for solar-powered habitats and equipment to function. Solar panels could become covered in dust, reducing their efficiency and potentially causing power shortages. Without a reliable power source, a colony could quickly run into serious problems. Dust storms are also a threat to equipment. The fine dust particles on Mars are highly abrasive, and over time, they can wear down machines and cause them to malfunction. Future Mars rovers and habitats will need to be designed with this in mind. Protective coatings and regular cleaning mechanisms will be essential to ensure that equipment continues to operate during and after a storm. What's even more terrifying is the size of these storms. They are not just localized events. Some of them can grow to encompass the entire planet. These planet-wide dust storms happen once every 3 Martian years, and they are nearly impossible to predict. If a storm of this magnitude hits during a critical mission, or while settlers are still establishing a base, it could set the entire project back by months, if not years. Scientists are still trying to understand why these storms occur and what triggers them. Some theories suggest that the storms are a result of temperature fluctuations between day and night, but the exact cause remains a mystery. With so much still unknown about the origins and behavior of these storms, the danger they pose to human missions cannot be understated. To survive a Martian dust storm, future settlers will need more than just basic shelter. They will need technology that can withstand the intense conditions and the ability to keep their habitats functional even when the entire planet is blanketed by dust. How can humanity protect itself from the fury of Martian dust storms? Will Mars' relentless dust storms become the greatest obstacle to colonization? Or can we find a way to survive and thrive in the face of such chaos? The extreme temperatures of Mars. Mars may be the red planet, but its temperatures are anything but warm. What would it feel like to step out onto Mars and face temperatures that swing from freezing to relatively warm in a single day? And how would a colony survive in such extreme conditions? The temperature on Mars varies dramatically depending on where you are. Near the equator, temperatures can reach a somewhat tolerable 20 degrees Celsius during the day, but at night, they can plummet to a bone-chilling negative 125 degrees Celsius. These fluctuations pose a serious threat to human settlers, who will need to find ways to protect themselves from the extreme cold. Unlike Earth, where the atmosphere helps to trap heat, Mars's thin atmosphere means that it cannot retain heat. This leads to extreme temperature variations, with the coldest nights on Mars being colder than anything humans have ever experienced on Earth. Even the best insulation will struggle to protect settlers from such cold. To survive these extreme temperatures, settlers will need to create habitats that can maintain a stable internal temperature. Heating systems will need to be designed to withstand long periods of extreme cold, and insulation will need to be far superior to what we use here on Earth. The right materials will be essential to keep the warmth in and the cold out. There's another problem too, keeping everything working in such cold. Any equipment that isn't properly insulated could freeze and break down. Solar panels, for example, would struggle to provide enough power when the temperature drops below freezing. This would require colonies to rely on alternative energy sources, such as nuclear reactors, to ensure a steady supply of power. Additionally, the extreme cold could have a significant impact on human health. Low temperatures can cause hypothermia and frostbite in minutes. Even the smallest mistake in preparation could lead to disaster. Settlers will need to be prepared for anything, from unexpected temperature drops to the risks of working outside in such a harsh climate. Mars's cold temperatures are one of its most dangerous aspects. While the planet offers opportunities for exploration and discovery, the conditions will require settlers to be incredibly resourceful. How will humanity adapt to Mars's freezing environment, and what technologies will we need to ensure survival? Can humans survive the bone-chilling temperatures of Mars, or will the red planet's icy grip prove too strong to conquer? Water, the ultimate resource. What's the most precious resource on Mars? It's not gold, and it's not even oxygen. It's water. Without it, humans cannot survive. And without enough of it, Mars colonization is impossible. How can we make the Martian desert a place where water flows freely? Mars is known to have a lot of water, but it's trapped in the form of ice beneath the surface. With temperatures so cold, liquid water cannot exist naturally on the planet's surface. But there is hope. NASA has been studying how to extract this ice and turn it into usable water. The first step in ensuring humanity's survival on Mars is finding a reliable and sustainable water source. Water extraction from ice is no easy task, however. The ice is buried deep beneath the Martian surface, sometimes hundreds of meters down. Getting to it will require advanced drilling technology, but even then, the extracted ice must be melted, purified, and then distributed for use. Any water collected will have to be used wisely, as Mars has no natural replenishment system for fresh water. But water isn't just necessary for drinking, it's crucial for everything from agriculture to energy production. If we want to grow food on Mars, we'll need a steady supply of water. And if we want to generate energy, water will be essential for powering things like fuel cells or even nuclear reactors. Without water, Mars colonization would be impossible. NASA is already working on technologies to help extract water from Mars's ice deposits, such as the icebreaker drill, which will be capable of reaching beneath the surface and bringing up the ice. Once the ice is extracted, it can be processed and purified for human consumption. This process could be crucial for future Martian settlers who need to secure a constant water supply. To survive on Mars, colonists will need to recycle every drop of water they have. NASA's spacecraft and the International Space Station already rely on water recycling systems to ensure that astronauts have enough water for their missions. This technology will need to be expanded and improved for long-term Martian missions, as it will be the key to keeping settlers alive. Water may be the ultimate resource on Mars, but obtaining it will be a monumental challenge. Without water, colonization is impossible. But with the right technology and resourcefulness, we may be able to unlock the planet's hidden water reserves and make Mars a habitable world. But is that enough to ensure the survival of humanity on the red planet? Can humans extract enough water from Mars to survive? Or will the red planet's scarcity of liquid resources doom our future settlements? Creating a sustainable energy supply on Mars. Imagine a world where the sun barely shines, where the wind is almost non-existent, and the only source of energy comes from a barren, lifeless landscape. This is the challenge that Martian colonists will face. Mars may hold the key to humanity's next great adventure, but without a reliable and sustainable energy source, colonization is impossible. The question becomes, how can we power the future of humanity on the red planet? Mars is incredibly different from Earth, particularly in its approach to energy generation. With a thin atmosphere that's only about 1% the density of Earth's, the planet's ability to harness solar energy is severely limited. Mars only receives about 40% of the sunlight Earth does, and this is compounded by the planet's frequent and intense dust storms, which can last for weeks or even months. These storms can blot out the sun and drastically reduce the effectiveness of solar panels, which means settlers cannot rely solely on solar power to sustain life. So, what alternatives do we have? Nuclear energy stands out as one of the most promising options. NASA has already begun developing small, portable nuclear reactors designed specifically for space exploration. These reactors are designed to generate continuous and reliable power, unlike solar energy, which can be unreliable due to the planet's atmosphere and weather conditions. The success of these reactors in previous missions, such as the ones used by NASA's Curiosity and Perseverance rovers, proves that nuclear technology can work on Mars. In fact, a portable nuclear reactor could potentially supply the energy required to power habitats, life support systems, and scientific equipment. Even during dust storms, or the long Martian nights when sunlight is scarce. But nuclear energy is not without its risks. Despite its reliability, nuclear reactors pose the potential dangers of radiation leaks, malfunction, and waste disposal, all of which must be addressed before they can become a viable solution for long-term habitation. And these concerns aren't limited to just the reactors themselves, but also the safe transport and setup of such large-scale energy generators. The technology to safely build and manage a nuclear reactor on Mars is still in its infancy, making this a massive hurdle that must be overcome if it's to become part of Mars colonization efforts. The next challenge is how to harness and store energy. Once we generate power, how do we store it effectively for times when energy demand exceeds production, such as during dust storms or the long Martian night? Advanced energy storage technology will be crucial to ensure a steady power supply, especially when solar panels are unable to collect enough energy. Current battery technology isn't sufficient for long-term use on Mars, so significant advancements in energy storage will be necessary. The introduction of new technologies, such as hydrogen fuel cells or more efficient battery storage systems, could help solve this issue. Additionally, the unique environment on Mars requires us to think creatively about where to get our energy. One potential solution is to tap into Mars' natural resources. Mars has an abundance of carbon dioxide in its atmosphere, and scientists are exploring ways to convert CO2 into usable energy. This process could be carried out using chemical reactions or through a technology known as CO2 reduction, which could potentially produce methane or even electricity. However, these methods are still experimental, and while they show promise, they are far from being ready for implementation on a large scale. Beyond energy generation and storage, the ultimate success of Mars colonization will hinge on how we use and conserve energy. If settlers can develop a system that allows them to produce, store, and use energy efficiently, they will be able to live and thrive on Mars. This means developing systems to optimize energy use in habitats, farming, water processing, and all other aspects of daily life. Moreover, the colony will need to be self-sustaining, generating enough power to maintain infrastructure, communications, and life support systems without relying on Earth for frequent resupplies. The importance of energy for Mars colonization cannot be overstated. It will be the lifeblood of every Martian settlement. From generating oxygen to powering life support and farming systems, energy will drive everything. As humanity prepares for this incredible leap into the unknown, the question remains, can we develop the technologies necessary to power Mars colonies? Will nuclear reactors, alternative energy systems, and innovative storage solutions be enough to sustain a permanent human presence on the red planet? Can we overcome the challenges of generating, storing, and using energy on Mars? Or will the planet's harsh conditions prove too much for even the most advanced technologies? The psychological challenges of Mars colonization. Picture this: you're thousands of kilometers away from Earth, cut off from friends, family, and everything you've ever known, with no immediate way to return home. You're not just facing the Martian environment, but the mental strain of isolation, confinement, and extreme living conditions. As exciting as the idea of colonizing Mars sounds, the psychological challenges of living on the red planet are vast, and no one knows how humans will truly cope with such extreme circumstances. Being separated from Earth for long stretches of time, with limited communication, will be one of the most difficult aspects of living on Mars. Communication with Earth has a built-in delay due to the vast distance. Any message sent could take anywhere from 3 to 22 minutes to arrive. This delay makes real-time communication impossible, which means that astronauts won't have the luxury of making a quick phone call to family or friends for emotional support. In emergencies, they would have to rely entirely on their colony's resources and their own mental resilience. Psychologists predict that the prolonged isolation and confinement could have serious consequences on mental health. Being stuck in a small, enclosed space with the same group of people, and with little to no contact with the outside world, could lead to feelings of loneliness, anxiety, and depression. In extreme cases, it could even lead to breakdowns. Or worse, This is compounded by the stresses of the harsh Martian environment, extreme cold, lack of sunlight, and the constant threat of dust storms. Every day would be a struggle to maintain mental clarity and emotional stability. NASA has already started studying these psychological effects by conducting simulations on Earth. One such study, known as the Mars Society's Mars Desert Research Station, simulates the experience of living on Mars by placing volunteers in isolated habitats for extended periods of time. These simulations help scientists understand how isolation, confinement, and resource scarcity affect mental health. However, no simulation can fully replicate the actual experience of living on Mars for years at a time. The true psychological toll of a Martian colony will only be understood when people are actually living there. The physical and emotional strains of Martian life will be exacerbated by the unforgiving environment, with limited space to move around, and the constant knowledge that you're cut off from the rest of humanity. Stress levels will likely be high. Add to this the constant struggle to survive, ensuring that habitats remain pressurized, that crops are grown, and that the life support systems continue functioning, and the mental health challenges will be unlike anything humans have ever faced. One of the greatest challenges will be dealing with the monotony and lack of variety. There will be no way to escape the environment, no change in scenery, and no socializing with new people. The same small group of people will be your entire social circle, and the same few activities will occupy your day. This repetitive cycle can lead to a sense of stagnation and hopelessness, something that's already been observed in isolation experiments here on Earth. How will colonists cope with such unrelenting monotony? And what happens when tensions inevitably rise? The psychological well-being of Mars settlers will be just as important as their physical survival. To ensure that people can thrive in these extreme conditions, new technologies and strategies will need to be developed. NASA is already investigating methods of improving psychological resilience, including regular mental health check-ins, creating engaging work and recreational activities, and providing ways to stay connected to Earth. Some even suggest incorporating virtual reality experiences to simulate interactions with loved ones and provide mental breaks from the harsh Martian reality. Ultimately, humanity's success in colonizing Mars won't just depend on our ability to adapt technologically. It will rely heavily on how well we can manage the psychological aspects of living on the planet. If mental health isn't given the attention it deserves, it could become the breaking point for entire missions. Are we truly prepared to face the extreme psychological toll of long-term Mars colonization? Will technology and resilience be enough to help people cope? Or will the mental strain of living on Mars prove too much? Can humans develop the mental resilience needed to survive on Mars? Or will the isolation and harsh conditions of the planet prove too much for even the most prepared individuals? The future of Mars colonization. Mars presents an incredible opportunity for humanity, an entirely new world to explore, settle, and perhaps call home. But as we've discovered, this dream of colonizing Mars is fraught with challenges, many of which we have yet to fully comprehend. From the dangerous radiation on the journey to the psychological stress of living in isolation and the planet's extreme environment, the obstacles are as daunting as they are fascinating. As we move forward in our quest to establish a permanent human presence on Mars, we must not only push the boundaries of technology, but also develop the mental and physical resilience to survive in one of the harshest places known to humanity. Solutions like nuclear power, innovative habitat designs, and advances in psychological support will play a crucial role, but the real test will be our ability to adapt to an environment so fundamentally different from Earth. While Mars might be a barren wasteland now, the potential for human settlement is undeniable. The technologies, strategies, and discoveries we make over the next few decades will lay the groundwork for future generations to thrive on the Red Planet. It won't be easy, and it certainly won't happen overnight, but with persistence, innovation, and determination, humanity could overcome these challenges. The quest to colonize Mars will define a new era of human exploration. Whether we can successfully build a sustainable, self-sufficient colony will depend on the collective effort of scientists, engineers, and astronauts working together to solve problems we've never faced before. It is a challenge that will require the very best of humanity to accomplish. As we stand on the brink of one of the greatest adventures in human history, we are reminded that the path to Mars is not just about technology and science. It's about the people who will make it possible. It's about overcoming obstacles, learning from our mistakes, and relentlessly pursuing our goals. So, what do you think? Will we conquer the challenges of Mars colonization, or will the planet's harsh environment prove too much for us? Only time will tell. If you enjoyed this deep dive into the future of Mars, don't forget to like, comment, and subscribe for more thrilling content. And if you're excited about the possibility of human life on Mars, make sure to hit the notification bell so you won't miss our next video. Join the conversation and share your thoughts on what humanity's future on the Red Planet could look like.